Hi. So the fourth algorithm is known as the merge sort algorithm, which I believe many of you are very familiar with already. So we covered it a little bit in the divide and conquer. So it shouldn't come too much of a surprise, hopefully doing this very short video. In the divide and conquer, what we want to do is we want to divide the unsorted list into two equal parts, and then recursively apply the merge sort algorithm. So simply saying that I'm not sure how these lists are going to be sorted, but I'm going to split them up first and then let the sorting process take care of itself. What happens is that, as you've seen earlier, the first part of the sorting process requires very little work from the algorithm. So it is merely dividing up the list into two parts. The work is all done in the merging part of the algorithm. So in this division, no work is being done, but work is being done only in the merging part of the algorithm. So this division is done until we are so-called left with just the single elements. And when we're left with that, then we start with the merging parts where they are merged together, and the order whereby they are to be arranged in is being taken into account. As an example of how we do it, we have, let's look at these two arrays. Initially, we have index A, index B. The pointers will be at index A, index B. We're going to be comparing the numbers between two indexes. So at first, 1 will be compared to 2. 1 is smaller than 2, and the smaller one we place into the final array. Then index A will be moved to the right. Next thing, we'll compare between 3 and 2. This is smaller than 3, and so 2 will be placed in the array C, and the array B will be moved to the right. Then again, 3 will be 3. So now at this point of time, we have 3 numbers to be the same. So we now have a choice which one to take. In the implementation of the algorithm, I would prefer that the array that comes first will have the number coming into the combined array first, meaning that if this array comes before this array in the original unsorted array, this number should come in first before this number. And I'm going to share why do we do that later on. So we put in the number from array A first, and we increment index A. Now 5 will be compared with 3. 3 comes in and move index B to the right. 5 with 6, move 5 down. I believe that you're beginning to find another pattern. 6 with 8, move 6 down. 8 with 7, move 7 down. Now we reach the end of the array B, and the rest gets copied into array C. So that's how merge sort actually works. So this is the merge sort algorithm. So meaning that once and this is the so-called the divide stage. This is the divide stage where we are going to divide the first part and the second part. So until I get to my minimal element, I will continue to divide it with the first half and the second half. The work is done only in the merge stage, which is what we are seeing over here. So this is where all the work is being done in. The rest of the divide stage actually does not require any work at all. So I believe we talked a little bit about this the last time. So the merge step has an ON algorithm, and the height of the tree is big O of log n, and so in total it is n log n. The space complexity, we don't cover this a lot in this course, but it is good to note that merge sort requires the use of an external sorting array. And so there is an additional space complexity required for merge sort. I talked a little bit earlier about why do we want to put index A first rather than index B. And we'll see this later in our tutorials as well. The key reason is that we want, as much as possible, we want our arrays to be, we want our sorting algorithms to be stable. What we mean by stable is that if this tree comes first in my original unsorted array, I want it to come first again in my final sorted array. If this tree comes second in my unsorted array, and there are two trees there, I want them to come in again second in my sorted array. So that is the definition of a stable algorithm. By right, merge sort is supposed to be a stable sorting algorithm. Some of the algorithms that we've seen earlier, they're actually not stable. And you can tell, and I think it'd be good for you to do as exercise, which of the algorithms are stable, which of the algorithms are not stable.